This is a story about Mission 33, a military mission flown on Discovery in November 1989. I'm Fred Gregory, the commander.
I'm John Blaha. I was the pilot of the flight.
I'm Kathy Thornton. I was Mission Specialist 3.
I'm Story Musgrave. I was MS2.
I'm Sonny Carter. I was the MS1.
This is about 3 hours before launch when we get in our suits, and now we're leaving the building about 2.5 hours to get in the crew van about 4:30 in the afternoon for a night launch.
Yeah, it's just before sunset. Discovery is sitting out on the pad waiting for us. It was one of those exceptionally clear nights down in Florida.
Everything went pretty smoothly right up to the end.
And we had a little hold as we were counting down, but essentially we launched right on time. When those main engines started, it felt like some electric motors back there, but when those solid rockets ignited, there was no doubt this thing was going to space.
The people in the front seat were looking out the front windows. Those of us in the back were looking out the back windows. That's where the view was.
And those of us on the middeck were looking at the galley and the lockers.
I wore this mirror on my wrist and looked out the rear windows. You could see the whole of Florida lit up like a flashbulb.
This is a lot like training to me. It was like riding a train, kind of a rumbling until the solids fell off, and then it was really smooth.
I never made a night launch before, but when those SRBs separated from the orbiter, as you looked out through the front window at the separation motors, it looked as though you were looking into a furnace.
And then the 3 main engines kept pushing us towards space. And it's kind of neat that you go from 0 speed on the pad, 8.5 minutes later, you're doing 17,500 miles per hour.
Space is just about as beautiful as you can imagine. Look, it looks like black velvet with diamonds on it.
This is kind of a game of ring around the rosy between the middeck and the flight deck.
It was really our first experience in 0G up there.
Yeah, you can see what happens to your hair up there in space. It sure takes on a different style.
This is Dr. Carter. He's the ex-professional soccer player.
You see what I told you about your hair up there?
That's Dr. Musgrave with all his degrees, Mr. Spock.
Here comes John doing an outside loop, isn't it?
Yeah.
I'm strapped to the wall there, and Story's gonna use this tonometer here to see what the pressure is in my eyeball. It's one of the medical experiments we were doing, and you get Story taps that on, right on my cornea, and it reads a reading that we can then record.
See, it doesn't hurt at all.
Now I've switched with Story, and I'm just kind of showing you the method, although I'm not touching Story's cornea here.
The reason we're doing this is because we're very interested in how the body changes and adapts very quickly to microgravity.
This is a Holter monitor, and these are the leads it's like a cardiogram that continually records my heart rate and its form. And when I close the door, it'll start here, and I've connected the leads, and I'm just showing you what it records here. And then I wore this underneath my suit all the way to landing. John, what did you think of this experiment?
Well, this was another experiment where Sonny was measuring data on all of us and central venous pressure, and I really didn't know much about it. I was just a participant.
Well, that's a transducer I've got there, and what I do is put that over the external jugular vein on John's neck, and John then blows into that piece that you saw in his mouth and creates a pressure. And that occludes the sound that I can receive through the transducer, and I'm listening to it on those earphones, and we record what pressure it takes to occlude that pulse. And by that, we can indirectly see what central venous pressure is.
This is an eye doctor in a box experiment. There are 8 different eye tests in that box, and we're looking at how vision and visual acuity might change when you go into 0G. You also notice the pen. It takes rookies a while to learn that they can let go of things and expect to find them somewhere near where they left them. This is another experiment we did on board. I was looking at the shuttle glow through a spectrometer. When the orbiter is crashing through the atomic oxygen, which is at probably less than 160 nautical miles, you'd see a glow on the windward side of the orbiter. And there are people trying to figure out the mechanism that causes that.
Most of the time I spent in the commander's seat looking out of the window. We create our own electricity on board. We combine hydrogen and oxygen. One of the byproducts is water, and when we dump that water overboard, it immediately freezes, and this is the blizzard that you see from the window.
This was a test that we did on board trying to demonstrate that we could take marks on stars and planets by moving the spaceship around and align our navigation state by doing that, and we demonstrated on this flight that we could in fact do that.
Another thing we did was record the radiation dosage that we were receiving. This little box calculates it in tissue equivalents, and we would record it each day and change out a memory module that actually recorded it by the minute.
This is the way Houston sends messages up to us on a teleprinter, and then somebody answers the telephone and talks to them.
On my right side up here, what I'm doing is changing out the lithium hydroxide canisters. That's a chemical that the cabin fans blow air over, and that absorbs the carbon dioxide from our respiration. Otherwise, the carbon dioxide would build up in the cabin.
We breathe an atmosphere of air, 20% oxygen, 80% nitrogen. Of course, we exhale carbon dioxide, and we recycle our air on orbit.
You do this twice a day, isn't that right, Scott?
Yep. Once after getting up and once before going to bed.
The text and graphics system here wasn't operating just right, so Kathy and I attempted to clear a jam that was in there.
We carried quite a complement of cameras with us. This was a 16 millimeter. I think we were trying to attach to the orbiter electrical system.
It didn't run very well on the batteries, so we used what we call a breakout box to change the voltage of the spacecraft to the voltage required by the camera. This did get it working.
In the background are the trays for food. I'd never noticed, but looking out the window, you can hardly see any motion on the earth below you.
This is the Namibian desert, southwest coast of Africa. And we're crossing Africa west to east, looking across the Kalahari Desert, up over to the east coast of the African continent, and then up onto the horizon of the Earth here.
Yes, South Africa would be to your right, Angola to your left. This is the flight deck, and this is Sonny looking out of one of the overhead windows down at the Earth, looking down at the Red Sea and Yemen and Saudi Arabia, Ethiopia, Egypt up to the upper left, and Iraq on the upper right. Moving at about 5 miles a second, but from that altitude it appears as though you're merely creeping across the Earth.
We had several different types of cameras, and we would shoot a few shots with one and then pass it off to someone else.
It's so funny when you try to do that when you get on the ground, everybody's so surprised that things immediately crash to the floor instead of floating gently.
This is Lake Kariba in southeast Africa. If you remember, in 1965, there was the Operation Noah in that area to save the animals. And so we were able to photograph that for some geologists that were interested in it.
Well, that's part of the African Rift.
Yes, it is.
It's just like being a tourist, except you're out in space. You've got cameras and you've got a window. And you take things which are maybe scientific, but also things that appeal to the eye.
This is India at the top of the picture, China in the bottom, and the Himalayas, where the former continent of India has collided into the continent of Asia, creating those mountains.
You have to shoot pretty fast. You don't ask questions at 300 miles a minute. You need to get the photograph and ask later what you took.
There's a lot of room up there to get everybody in the windows, though. Looks like a small area, but you could get the entire crew up there taking pictures all at the same time if you wanted to.
This is the Namibian coast again, and this time we're on a ascending pass through Africa, so we're going through Angola.
Those are two different kinds of clouds there. I mean, easily seen, aren't there? I mean, one's kind of a sea fog at the bottom left, and the other were kind of the wispy cumulus clouds.
John took a lot of pictures, and every time he took a picture, he said, boom, every time.
Watch his lips here. Watch this. Watch, John. He's talking a minute. Here we go. Boom. You can watch the camera move around there every time he says it.
These are the Indonesian islands that we had to pass west to east across them. And normally this part of the world is very covered with clouds, but on our mission it was clear, and so we were able to get some beautiful pictures coming across the Indonesian islands.
It's mostly volcanic. We were learning quite a lot about our world by looking down at parts such as this, but it's so interesting to look down at the oceans from the altitude with the proper sun angles. You get pretty good insight on the dynamics of the oceans down there.
This is a beautiful infrared picture that Kathy took of the Irrawaddy River Delta. She really did a good job with the infrared. And this is off on the east side of Madagascar, an island that has two beautiful volcanoes in it, Reunion Island. Again, an infrared photography of it. The geologists were very interested in that particular feature.
This is chow call for Thanksgiving dinner. We launched the day before Thanksgiving in 1989. And so we had our turkey and potatoes and broccoli on orbit, probably a day later than people on this planet. But you get a little confused about what time of day it is when you're up there. You see sunrise 16 times a day. It's hard to tell what meal you ought to be eating.
Translation and attitude control are almost done completely with your hands. Very little feet there except then to maintain a position once you get there.
I guess you see people moving very slowly, too, so that they won't ricochet off walls. But this was the Thanksgiving meal, and I think it was the only meal where all of us floated together and ate at the same time.
KT's got the maggot on board sign there. Our class in 1984 were known as the maggots affectionately by all the astronaut office, and we carry that on the missions with us. What do y'all think Fred's doing here? Looks like his body's moving, and yes, the answer is he is dancing. Four Tops, Temptations.
This is the commander of STS 33.
That's right, our commander.
Yes, I think everybody wore Walkman all the time, and everybody had their own specific music that they listened to. There were a lot of soccer players on board. John Blaha coached and played. Sonny, of course, was a professional soccer player. Kathy, being from the University of Virginia, was a pro, and we learned from her.
Not hardly.
Virginia were national champions.
We each get to take one or two things just to remind us of home. And generally a plug for our alma maters is one of them. And a picture of the family is nice to have.
Kathy, the picture's upside down. Oh, that's better.
There's John plugging his university, and I watch him kick this piece of scientific gear here. Pow!
Small college in the South here.
It's the world's greatest medical school.
We carried a lot of dinosaur cookies up there, but we ate all of them except one.
Skip, John ate all of them.
That's right.
Oh, John ate all of them.
This looks like a bunch of grown-ups playing with their food, but actually this is a physics lesson. If you remember, the hardest thing to teach students in physics is the difference between mass and weight. Well, up there, everything is virtually weightless. However, it still has mass. If you watch how the gummy worms and the goldfish move, the goldfish is less massive and moves very quickly.
I had to take this hat. I'm what I thought at that time the world's biggest Dodger fan, and those glasses came from my daughter to complete the set of Los Angeles kind of stuff.
I'm glad you described that, Senator.
And just the crew picture with a standard Hi Mom sign.
We forgot the one about send money.
We deorbited and landed at Edwards Air Force Base just before sunset. We landed on runway 04, a runway that we'd never used before landing the orbiter. And we landed right on time and within about an inch or so of where we were supposed to. Touchdown was smooth and rolled out just as the sun dipped below the horizon.
Fred, I think you're about ½ an inch to the right of center line.
We'll have to do it again.
And 1 mile per hour slow.
The next shot is the same approach, but it's an infrared shot and gives an indication of the temperatures on the orbiter during the approach. The whiter the surface, the hotter it is. But the very interesting thing is, as the wheels come down, they're very gray, indicating they're cool, but as they touch down, those tires really heat up. It's tremendous technology that allows that kind of material to be built.
You can see the bottom of the orbiter there is so much hotter as the wheels touch down than the top and around the cockpit, and of course the nose being the hottest, but it's really dramatic difference there.
That's the auxiliary power unit's exhaust up near the base of the tail.
If you change the polarity of this picture and make the hot parts dark, then the orbiter looks just like a regular orbiter, except you can't read Discovery on the side.
We had these launch and entry suits on when we came in, and it was very cold outside, but with the suits and the combination of us trying to become Earthlings again, all of us were very hot when we came outside.
It takes a while to get your Earth legs back. There was a lot of staggering going on out there, but that's one tired and happy crew.
We're ready to go again.
Absolutely.
This is a lot like training to me. It was like riding a train, kind of a rumbling until the solids fell off, and then it was really smooth.
I never made a night launch before, but when those SRBs separated from the orbiter, as you looked out through the front window at the separation motors, it looked as though you were looking into a furnace.
And then the 3 main engines kept pushing us towards space. And it's kind of neat that you go from 0 speed on the pad, 8.5 minutes later, you're doing 17,500 miles per hour.
This is a story about Mission 33, a military mission flown on Discovery in November 1989. I'm Fred Gregory, the commander.
I'm John Blaha. I was the pilot of the flight.
I'm Kathy Thornton. I was Mission Specialist 3.
I'm Story Musgrave. I was MS2.
I'm Sonny Carter. I was the MS1.
This is about 3 hours before launch when we get in our suits, and now we're leaving the building about 2.5 hours to get in the crew van about 4:30 in the afternoon
It's just
for a night launch.
Yeah, it's just before sunset. Discovery is sitting out on the pad waiting for us. It was one of those exceptionally clear nights down in Florida.
Everything went pretty smoothly right up to the end.
And we had a little hold as we were counting down, but essentially space is just about as beautiful as you can imagine. Look, it looks like black velvet with diamonds on it.
This is kind of a game of ring around the rosy between the middeck and the flight deck.
It was really our first experience in 0G up there.
Yeah, you can see what happens to your hair up there in space. It sure takes on a different style.
This is Dr. Carter. He's the ex-professional.
We launched right on time. When those main engines started, it felt like some electric motors back there, but when those solid rockets ignited, there was no doubt this thing was going to space.
The people in the front seat were looking out the front windows. Those of us in the back were looking out the back windows. That's where the view was.
And those of us on the middeck were looking at the galley and the lockers.
I wore this mirror on my wrist and looked out the rear windows. You could see the whole of Florida lit up like a flashbulb.